Hi guys, welcome to Colossal Mathematics class. Nice meeting with you guys again. Don't forget to subscribe if you've not done that, like and share this video. Alright, in my last class I discussed about geometry on equation of finding equation of a straight line, and in today's class I'm going to be talking about perpendicularity and parallelism of a straight line. So here we have the conditions necessary for a line to be perpendicular and for a line to be parallel, where our m here means gradient. So when you see m, it means gradient. So all we are going to be dealing with in this particular series is more of gradient. So if you have not seen my video on gradient, you can check the link in the comments. You can check the link in the description. You will see the link to watch the video on gradient, so you can have an adequate understanding on gradient, which I'm going to be using in this video. Alright, so the first condition for two lines to be parallel is that the first gradient must be parallel, must be equal to the second gradient. That is, if I have an example, let's say find if AB and PQ are parallel. It means the gradient of AB must be equal to the gradient of PQ. If they are equal, then you say the line is parallel. And if AB is parallel to PQ, we write it as AB parallel to PQ. So this line means parallel. Are you getting what I'm saying now? So this line is used for parallel. So let's get to perpendicular. So for perpendicular, it means if the multiplication of my m1 and m2 gives me -1. If I multiply my first gradient with my second gradient, if it gives me -1, then I can say that they are perpendicular. Or if my m1 is equal to -1 over m2, then I can also say it is it is perpendicular. And if AB is perpendicular to PQ, we'll write AB perpendicular to PQ. So this line, this sign here means perpendicular. All right, so don't forget I'm talking about perpendicularity and parallelism. So let's see some examples. So we are going to be seeing these two examples today, where to check if AB is parallel to PQ or perpendicular to PQ. All right, so let's see. In our example 1, we have our A to be 3, 1, and we have our B to be 4, 3, while we have our B to be 4, 6, and our Q is 5, 8. So we want to check whether AB is parallel to PQ or AB is perpendicular to PQ. So how will I do that? The first thing I need to do is to get the gradient of AB. So how will I get the gradient of AB? Let's call that M1. So our M1 is y2 minus y1 over x2 minus x1. And that will give us what's your y2? This is your y2, 3 minus y1, 1, all over x2 is 4 minus x1, which is 3. So that's 3 minus 1, 2 over 1, and that's giving me 2. So my m1 is 2. Now my m2, which is for PQ, the same formula, y2 minus y1 all over x2 minus x1. So my m2 will now be what's our y2? Y2 is 8 minus y1 6. So 8 minus 6 over 5, 4. So 5 minus 4, and that gives us 2 over 1, and that's 2. So you can see here that m1 is equal to m2, and I told you that when m1 is equal to m2, it is it is parallel. So since m1 is equal to m2 here, then I can see that AB is parallel to to PQ. Do we get that now? So it is as simple as that. All you just need to get is your gradient. So let's see the second example to see whether it is also parallel or perpendicular. All right, so the second example, we have our A to be 5 and minus 1, and we have our b to be 3 and 2, and we have our p here to be 2 and 4, and then we have our q to be 5 and 6. So are they parallel or perpendicular? You can pause this video and check it on your own to know whether they are parallel or perpendicular. Alright, so let's get our m1 as we did in the first example. Our m1, still the formula is y2 minus y1 over x2 minus x1, and our m2, let's do that together. M2 is equals what? Y2 minus y1 over x2 minus x1. So what is our m1 going to be? That's what we have to check for first now. So our y1 2 minus, now in our y1 we have minus 1, so you have to be in bracket, so minus 1 all over x2 3 minus x1 5. So that will be 2 plus 1, minus and minus will become plus, so 2 plus 1 will give us 3 over 3 minus 5 will give us minus 2. So therefore our m2 is, our m1 is equals to what? Minus 3 over 2, because minus cannot be in the denominator, it has to come to the numerator. So we have minus 3 over 2 here. So for our m2, our y1 is what? 6 minus, our y2 is 6, our y1 is what? 4. So that's 6 minus 4, and our x2 is 5 over x1 is what? 2. So that's what? 3 over 2. Now you can see here I have minus 3 over 2, here I have 3 over 2. So are they parallel? No. So let me check if they are what? Perpendicular, because if they are not parallel, then they have to be what? Perpendicular. So using my perpendicularity formula, which says that m1 multiplied by m2 should give me what? Minus 1. So if I multiply my m1 with my m2, if they give me minus 1, then they are what? Parallel. Alright, so let's check for that now. Don't forget to subscribe, like and share this video. So m1 m2 should give me minus 1. So what is my m1? My m1 is what? Minus 3 over 2 multiplied by 1 m2. My m2 is what? 3. My m2 is 3 over 2. Sorry, my m2 is 2 over 3 here. 6 minus 4 is 2. 5 minus this is 3. So that's 2 over 3. 2 over 3. So 2 will cancel 2. This will cancel this. So I have minus 1. So since m1 m2 is equals to minus 1, therefore AB is perpendicular to what? PQ. So thank you for watching this video. Don't forget to subscribe to this channel, like and share this video. In my next class, I will also be talking about the other important topic on finding general equation for straight line using this perpendicularity and parallelism with other equation on a straight line. So don't forget to subscribe, click on the notification bell so you can get to be notified when other videos are being uploaded. Thank you very much for watching, and do have a